Okay, so this one's a really good one. This one's a discrepant event. It's something that you definitely would not expect to happen. So what we have here is the first bulb is really bright, and this volt, you can see with the calculations from the voltage and current, so power equals IV, that the wattage is large in comparison. And we can also see what the with those numbers there, we can also work out what the resistance is, which is 18.75 ohms. Now the less bright bulb, you can see from the current voltage readings, the power released is much smaller, and so it's less bright. It's only 0.24 released, and this one has this resistance is larger. It's 37.5 ohms, so that sort of makes sense as well. But what doesn't make sense is when you put the two together. So the top one is the less bright, and now I've added the bottom one, which is the super bright one. You'd expect the super bright one to be brighter, but it's not. It's the complete opposite. So the less bright bulb is actually brighter when you put the two in series. And so if you look at the calculations there, because voltage splits in series, and the one with the greater resistance will get the greater voltage drop. So there's more volts going through the one with the larger resistor. So if you look at the two voltage readings, the power readings, P equals IV, that means the larger voltage drop will will have more power. So it has a larger watts going through it. So more power is energy per time, so more energy being released, so it's more bright. So in series, the less bright bulb shines up because the less bright bulb has a higher resistance and takes a larger voltage drop, hence more power or energy is being released. Not what you'd expect.